And look at these questions, find one you want to see, do go over, have questions about. If you don't have your calculator, go ahead and go grab that. So we'll start with those two. If we have other questions, we can do that. 76, there are two different ways to do this one, in the calculator or algebraically. Which one would you rather see, or do you want to see both? So we'll do the calculator first. Reset your calculator before anything. Second place 712. And then similar to the last thing we talked about, the line best fit, we're going to do those same steps, but with that problem. I'll put this in front of me. So go into stat. In stat, go into edit. So you can take out your review unless you need another one. Into edit 1 or enter. And put in, I'm sorry, I skipped this out. We are going to put in the numbers given, but you need to know which one is which so go down. In this example, so these word problems are either set up in y equals mx plus b, or you have two different things and you're comparing them. This is, if you have a certain amount of square footage, it costs a certain amount. So this is like your input and output, where you're not given an M or a B, and our goal is to find those things. So in your stat edit, you're going to put 850 and 1000 in for L1, or your X's, and 1172 and 1268 in L2 for Y's. And then once you have that data in there, go back into stat, scroll over to calculate, to the right, and you're looking for linear regression number 4. Because this question is asking about a specific square footage, you can store this or not, it's just really up to you. So go down to store and hit alpha trace. And then either down to calculate, hit enter, or enter 3 times. I don't know if I actually hit enter twice, maybe. So this would be your equation. So even though it doesn't ask for that, you would write that down. I'm sorry, it did ask for that and more. Y equals 0.64x plus 6.8. So this equation would give us our M and our B, our M being the amount of, the price per square foot, and the B being our amount if there weren't any square footage, so like maybe a deposit of some sort. And then we have to figure out the monthly rent for 1,200 square foot, so you can either store this value for X in your calculator, look at the table, or you can just put 1,200 in here and figure out what Y is.
1,396.
And we have to put the label because we're looking for costs. If you wanted to do that process in the calculator, you could do exactly what I have, type in, or from this page, I could store 1,200 as X. So put in 1,200, type in the STO above on, and then X, and then enter. And since I stored the equation in my calculator, I can go back and hit auto trace and enter, and it would give me that same number. Or because I have it stored in the calculator, I could have went into second graph to look at the table, and to change this to 1,200, second window, and keep that, and go back, and you get that same number. So different ways to do it. There are multiple. So things you would need to look for. Make sure you're labeling what's what. So like we did here, these are X's and Y's. We didn't have N and B, but if you wanted to label them after you got the equation, do that. The equation itself, and then solving to get that final answer. Questions on that one before we continue? So because these are not two different things that you're comparing, it wouldn't be solved like 77. But in 77, the amount of nickels and dimes have no effect on each other. They have effect on the total. So because these are two different things, you're going to use two different variables. Let me put this on the side. X, Y. So when you are comparing two different things, you'll have 5 different variables instead of just Y, X, M, and B. The equation will be written in the format AX plus BY equals C. So whatever A is will be connected to X, whatever B is will be connected to Y. C in this case would be our total. So then we can start picking apart some of the pieces. The 545 would be C. Because that's our total. We know we're talking about nickels and dimes, and we have to be specific about what is that exactly. And that would be number of nickels, number of dimes, and that would be your X and Y, the things you don't know. And then A has to go with X, so A has to be something related to nickels. And the only thing that it doesn't say is the value of this. So you would set A to be the value of the nickels, and B to be the value of the dimes. Yes, Taylor.
For Y, you see the number of dimes, but it says 46 dimes on it.
Sure, I forgot. Sorry. I forgot it did say that. So, but X and Y are going to be similar. So if you know that the actual number is 46 dimes, then the other thing you're looking for is the number of nickels. But yes, it is like that. So when we go to put this stuff in, it'll look like 0.05. Don't know what X is, so that stays. You know, B is 0.10, so plus 0.10. Y is 46. And we know it equals $5.45. Then it just becomes, now we're solving for X. I just realized we didn't go back and do that on the breakaway for 76, so we'll go back and do that after this. So multiply the 0.10, 46. Get rid of that by subtracting. And then divide both sides by 24. And whatever that is should be our number of nickels. And these types of situations, if you get a decimal, something's off because we can't have point whatever of a nickel of a dime. You can go back and do 76 algebraically, and then we'll move on. So we did that mostly in the calculator, but if we wanted to do it algebraically, we'd still have to know that these are x's and y's. But because we have an x and a y and we're looking for m and b, we would have to find the slope. So do your y2 minus y1 over x2 minus x1. So this would be 1268 minus 1172 over 1000 minus 8. And you can put that all in your calculator at once or figure out what that is individually. So, however you find that, simplify it. You'll end up with a fraction 16 over 25. If you were to actually divide that fraction, you'd get that same decimal that we found before, 0.64. And then you would use that to find your b value. Your b value, you would have to use your point slope formula. So doing it algebraically is a lot of work, but you could do it. Pick one of the sets of x or y. I'm going to use the second one. So y minus 1268 equals our slope of 0.64. And then in parentheses, x minus 1000. You would solve that like normal, distribute. And then get y by itself by adding 1268 to the other side. Negative 640 plus 1268. And we did that same number that we got before. The rest of it would be the same. Put in 1200 for x and figure out the answer. So, algebraic method works if you forget how to do it in the calculator, but the calculator would be easier if you remember how to do that. Questions on either of those? Go on to the next page. So now we're in systems. What questions on this page do you want to see, do, go over, review? 78. I just remembered I have to send this email really quickly and then. So let's start with 78. These are already in slope-intercept form, so we just need to graph them. Start at your y-intercept, -4. Your slope is negative, so we can go up to left 1 as many times as possible. If we could go down to right 1, we would also do that, but in this case we can't. Draw the line, connect all your dots. And then the y equals -2, because it doesn't have any x's, you have to be careful with us. This is a y equal, so it has to be a horizontal line. So on your y-axis, find when y is -2. Put a point there and draw a line across. And my line is not very straight, but look for where do these two lines cross each other. And write that as a order pair. X, then y, then -1, -2. Questions on that one? $80 is similar. Graph them both. So for this first one, it starts at -1. The slope is 3/2, so and it's positive, so we can go up 3 to the right 2 as many times as possible. Or down 3, left 2 as many times as possible. Connect those dots, draw a line, make arrows at the end. And then do the same thing with the other one. This one starts at 3. Slope is the same. I can't really go up 3 unless you go off, but I can go down 3 and left 2 twice. If I wanted to go off the graph, that point would be there. Connect those dots, draw a line with arrows. Do these lines cross? No. So this would be no solution.
How do you know which way the line goes?
Depending on your slope. So positive is always going up and right, or down and left. Negative is the opposite. So it can go up and left, or down and left. Okay. Other questions on that one? $81, we have to solve both of the equations before we can graph them. Get them back into the slope-intercept form by subtracting 5x for the first one and subtracting x for the second one. For the first one, we have -y equals -5x minus 3. Second one, we have y equals -x minus 3. The second one is completely solved. We don't need to do anything else. But the first one, we still have to get rid of that negative. divide everything by that negative. And then graph both ones. So this first one would start at 3. And since it's positive, I can go up and right, but I can't go up 5. So instead, let's go down 5 and to the left 1. And that's as many points as I can fit on this graph. The other one's going to start at -3. The slope is -1, so we can go up 1, left 1, as many times as possible. Or down 1, right 1, as many times as possible. And then find where those two lines cross and write that in order. That one happened to cross at the same place the other one did. That was interesting. Questions on A1? A3 is the same way. We have to solve them both first. So subtract 2x to both sides, subtract 7x to both sides. For the first one, we have 3y equals -2x plus 3. The second one, we have 3y equals -7x minus 12. But then for both, you're going to divide everything by 3. Some of them, like the -2 to -7, will just remain fractions. And the y-intercepts you can simplify. And then graph. I'm going to do the second one first. Starting at -4, go up 7, left 3. And draw a line that connects those. And then graph the other. Start at +1. The slope is positive, so we can go up to right 3, down to left 3, and connect 3. Oh, that was supposed to be negative. That was my bad. So you may have just did the same thing I did. Because I forgot my name. It should be up to left 3 and down to right 3 instead of what I just said. And then find where they intersect, which would be at -2. Questions on systems by graphing? Go on to the next page. And systems by substitution, which of those do we want to see go over? So let's start with 84. The goal with substitution is you should have an equation that's already solved, either x equals or y equals, does not matter which one. And if you do have that, you're going to take this entire equation and replace the other y in the other equation with it. So I can rewrite this. Negative 2x plus 3, then in parentheses, negative 3x plus 21 equals negative 14. Then it's just a regular problem and we solve it, distribute. So minus 9x plus 63. Combine your like terms. And continue solving for x. Get rid of 63. But that's only part of it. You have to go back and find y. Take that number you found, put it back into your y equation, but now we're at x's. You don't have to go to errors, but if it helps you do that. So y equals negative 3 times 7 plus 21. Multiply that, combine those. In this case, they cancel each other out. And you would put those two things together as an ordered pair. And that would be your end final answer. Questions on that before we move on? So then 86 is the same way. We have an equation that's solved for y already, so we're going to take the equation and put it into the other y. Negative 2x minus, in parentheses, negative 2x plus 10 equals negative 10. When you distribute, you're only distributing the negative. And when we go to combine like terms, the x's completely cancel, this leaving us with negative 10 equals negative 10. This is a true statement, so this will be infinitely many. If your variables disappear and you get the same thing on both sides, infinitely many. If they disappear and they're not equal, no solution. '89 is a little different because it doesn't have a variable solved by itself, so you have to do that first. You can really choose either any of the variables, but I would look for the one that's by itself, because that would make your life the easiest. So in the first equation, let's solve for y, get rid of the 2x. That way you have an equation that's solved for one of the variables. Then you can take that expression and put it into the other y. It's important that you put it into the other one, not the same one, because then your variable will cancel. And rewrite it. And then start to solve that. So distribute the 3. In this case, we also have something where the variables cancel each other out. But here the numbers don't equal, so this is no solution. Other questions on this one? Go on to the next. Now we're doing systems by elimination, which is different somewhat than what we were just doing. Because in order to eliminate, the coefficients, the numbers in front of the variable, has to be the same. So of these ones, which ones do we want to see to go over? So 93, not only do we have to make sure that the numbers, the coefficients are the same, we also have to make sure they're lined up, because right now they're not. So you have a choice. You can either make the first one look like the bottom one, so move the x over to where negative 21 is, or make the bottom one look like the top one, so move the x over to where the y is. Which one do we want to do? First like the second, second like the first. The first like the second. Okay. So if we're making this one look like this one, we have to get rid of or move the x over. So add 8x. I'm going to rewrite this underneath. And rearrange. So now the x's line up, the constants line up, the y's line up. And we're looking to see if the variables have the same coefficient. Right now they don't. So we have to multiply the entire equation or both equations so that they're the same. You could choose either x or y. So if we chose x, we can multiply the bottom by 3, or negative 3. If we chose y, we can multiply the top by 3, or negative 3. Which one do you want to do? Multiply the top or multiply the bottom? So we make the top the same. We want our y's to eliminate. So we're going to multiply this entire equation by 3 or negative 3, doesn't matter. And then I'm going to rewrite that under here. Negative 72x minus elimination, as the type of solving suggests, we're trying to eliminate. So we have to think of, could we add these together? Would they eliminate, or would we subtract them? And if you're not sure, you could double check. Let's say I added them together. -9 plus a -9. That does not become 0. So it would have to be the opposite. -9 minus a -9. So I would be subtracting these entire equations together and seeing what's left. So we just found that -9 minus -9 is 0. -261 minus a -261 would really be adding. So +240. And then 8 minus 72 would be negative something. And then we would just solve for x. Get rid of 240. And divide both sides by -64.
So they can be decimals.
And then go back and put that in for y. One of the y's doesn't matter, I'm sorry, for x. One of the originals, one of the ones you changed, it doesn't matter which one. Let's say I'm just keeping this one. And then I can solve that one for y. -90 minus 87 equals -3y. And then divide both sides by 2. And then last step, just like the last one, write that as a order pair. If while you're solving you get decimals or fractions and the decimals aren't nice, leave it as a fraction. But in this case, it worked out, they were nice. Questions about 93 before we do 95? 95 will be less work because we don't have to make them the same. They already are the same. For this one, you could have left it as a fraction or changed it to a decimal. So if you go in, put in your decimal and type in alpha y equals, this last one will change it to a fraction for you if you want that. Right. And 95, everything lines up. The y's have the same value. So we don't have to change them. We just have to think, how could we eliminate them? And again, you could check if you're not sure, -1 minus -1, or -1 plus -1. but this case we would be subtracting the top from the bottom, or the bottom from the top, sorry, and seeing what's up. So 5 minus negative 7 would be 12x. Negative y minus negative y would just be 0. And then 19 minus a negative 29 would be and then solve for x. Really, I don't have to get rid of this 0 or do anything with it. I just need to divide both sides by 12. Then I would go and do the same thing for to find y. Put that back in. One of the y's does not matter which one. Let's say I choose the first one. Let's put in 4 instead of x. We have 20 minus y equals 19. You can either get rid of 20 and then divide, or get rid of y and then move it back. Your choice. And then write your final answer as a order. Questions on 30? $98 is similar to 93, except it's already lined up. We just have to, I'm sorry, it's not lined up. I lied. We have to make it line up. So let's say we made the bottom one. I'm trying to make it easy, right? Let's just move the 8 over. So subtract it to the other side. And then rearrange it and write it underneath. We have 9y minus 8x equals negative 11. And then you have to choose if you want to eliminate your x's or y's. Let's go x's this time, and you have to multiply them both by something so that they're the same. I know we could just multiply them by each other, so this one by 8 and this one by 10. But if you think of something smaller, you can always go with that, some number that they both go into. Negative 80y plus 80x equals 60. And then 90y minus 80x equals negative 100. Sorry. Then we have a positive and a negative version of 80. So we have to think about how could we eliminate them, add or subtract them together. I'm going to add them first. 80 plus a negative 80. That would cancel each other. The other one would not. So add the two equations together. Negative 80 plus 90 would be 10y. 80 plus a negative 80 would just be 0. 160 plus a negative 110 would be, and then solve for y. then you can take that y, put it back into any of the y's you had before, does not matter which one. Let's say I did the first one. Negative 11 plus 8 times x equals 9 times 5. And then you would be solving for x. So get rid of 11, add it to both sides. And divide both sides by 2. Still put it as an ordered pair, but you solve for y first, so that would go second. Do we have any others on the stage you want to see? Do you go over? Not go off the next page. So last objective in that unit, word problems of systems. Which of those do you want to see you go over? So the setup for these will basically all be the same. It just depends on how many numbers you're given and things like that. So as you get these, I would read through it, circle, highlight, underline any numbers you see, and then anything else you feel is important. For 103, important things, 11 adult tickets, 8 student tickets, total of 167. Other important things, $89, 5 adult tickets, 8 student tickets. When you're given 6, bless you, when you're given 6 numbers, you're going to use them all in 2 different equations. We are also looking for the price of both types of tickets. That's going to help you with your variables. You can call them whatever you want, A and S, X and Y, doesn't matter. So define your variables first. Be specific. We're looking for the price of an adult ticket, the price of a student ticket, the cost of or price of. Then we have to come up with 2 equations. We're given the totals 167 and 89, so those will be the 2 things these equal. And then the number of tickets is going to go with the variables, so 11 adult tickets times the cost, so 11A. Total we're adding. And then 8 student tickets goes with the cost of student tickets, so 8S. And then the same thing for the second one, 5A plus 8S. After you set up your equations, you have a choice of how you want to solve it, by graphing, by substitution, by elimination. Some will work better than others. In this case, we have the same number here, so elimination will work really well. To eliminate the s's, we would subtract. 8 minus 8 is 0. So subtract the 2 equations. and divide to solve for n. Since we're looking for the price, we have to label it as $13. Then go back and find your other one. Put that value into one of them, does not matter which one. And solve for S. After you solve for both, then you have both of your answers. (104) also has it's a problem with 6 numbers, so the setup will be similar. So important things in this one: 14 vans, 7 buses, 525 students. And then 7 vans, 5 buses, 342 students. The questions, we don't know how many students a van can carry, how many students a bus can carry. So those would be our 2 variables, V and B, or X and Y. And this would be number of students in each. Then we can set up our 2 equations. Number of vans or buses will go with number of students in each. So 14V. Total number of students that we're adding. 7B equals 525. And then we can set up the other one. 7B plus 5B equals 342. In this one, we're going to use elimination again because substitution, it wouldn't be very nice. You have fractions, and then graphing would also not be nice because we don't have nice numbers. So let's make these the same by multiplying this by 2. And then to eliminate 14 minus 14 would give us 0. 7 minus 10 would give us negative 3B, and then we're going to figure out that last one. 525 minus 64. Then we could solve for B, divide both sides. our label for this would be students. Or you could specify the whole thing, students in each bus. And then we could go back and find B. Put 53 into any of the equations you have. $7B plus 5 times 53 equals 3.5. And then solve for seven. And when you get your answers, double check them. If you have more, if you get a question like this and have more van students than bus students, there's probably something wrong there. Usually buses are bigger than vans, so buses should have more. Go on to the next section. So now we're in inequalities. Steps to solving them are the same as regular multi-step equations, except you have to worry about graphing. Which of these do you want to see solving?
What's up?
Let's do those, and then if we can do one more objective, we'll stop. So here we have to combine like terms when we do this work in this open space. 0 is greater than or equal to negative 11k. And then divide both sides by negative 11. Because we divided both sides by a negative, the sign will change. Because this is written backwards, you have to know how to graph it. You either have to read it backwards, starting with k is pointing away from, so that's greater than 0, or rearrange it. Make sure whatever direction is pointing to or away from the k is doing the same thing. This would be closed because of the equal to. At 0, going to the right. Questions on that one? One 10. We would need to distribute first. Keep everything from the other side. And then, like our regular equations, move all the constants to one side, variables to the other. So let's say I got rid of 7n and added 11. Then we have negative 15n is less than or equal to 6. divide both sides. Because we're dividing by a negative, the sign would flip. So this again would be closed, but this time at -4, going to the right. And then 111 is similar, except now we have to distribute twice. We have -16x plus 16 is greater than positive 24, not x, minus 8x. Move one of the variables to one side and the constant to the other. So let's say in this case I move 16x and get rid of 24. Then I could divide both sides by 8. Sign would not change because what I'm dividing is not negative. I could either read this backwards, x is pointing towards, so less than -1, or flip it. So this would be open at -1, going to the left. Questions on these? Go on to the next page, and then after we do examples on this, we will stop. Now we're on compound inequalities, which should be similar to what you were doing not too long ago in Unit 9. Which of those do we want to see do go over? We'll do those, and then if you have any others, we'll do that. So this is an OR because it says that, which means we're going to solve both of them separately. Add 7 to both sides on 1. So x is less than positive 3, sorry. Divide both sides by 5 for the other. When you're writing your final answer, put OR in between. The ORs graph away from each other. These will both be open circles at 3 and at 9, but facing out. Because there isn't an OR, this is an AND. So your goal is to get the variable in the middle by itself, get rid of everything else. But when you get rid of it, move it to all sides, not just one. So add 10 to everything. We have 7 is less than b, which is less than 9. These would both be open circles, but and graphs towards each other, so draw the line in between. Any others on this page you want to see we will go over? So then we'll stop for today. pick back up on 4.3 Thursday.